Hi everyone, I am Madam Osmaya. Welcome to my YouTube channel. In this video, we are going to discuss on mass defect and binding energy. So first of all, what is meant by unified atomic mass? So the unified atomic mass unit, we use symbols U, is defined as 1 per 12 of the mass of an unbound neutral atom of carbon-12 in its nuclear and electronic ground state and at rest. So 1 U equals to 1.66 times 10 to the power of negative 27 kilogram. So we are going to prove this. Okay, from the periodic table, we get the reading here shown 12.01 is the unit, is the mass gram per mole. Okay, we read from the periodic table, so this is 12.01 gram per mole. So we are going to use this to derive the 1U. And then we are going to use Avogadro number, 6.02 times 10 to the power of 23 atoms. So 1 mole contains 6.02 times 10 to the power of 23 atoms. And then the 12 gram per mole, we convert to kilogram. So 12 times 10 to the power of negative 3 kilogram. Okay, for 1 atom, how many kilogram? So we use a ratio method. So 6.02 times 10 to the power of 23 per 1. So divided equals to 12 times 10 to the power of negative 3 divided by Y. So the mass for 1 atom carbon-12 is equals to 12 times 10 to the power of negative 3 divided by 6.02 times 10 to the power of 23. So it is equals to 1.99 times 10 to the power of negative 26 kilogram. So this is a mass for 1 carbon-12 atom. Okay, how to relate to U, 1U, okay, unified atomic mass. Okay, this Y, what is means this Y? Okay, by referring to the carbon-12, okay. So since the mass of carbon-12 atoms is defined as 12U, so 12U is equivalent to 1.99 times 10 to the power of negative 26 kilogram. Therefore, for 1U equals to how many kilogram? So the same method we use ratio method. So 12 per 1 equals to 1.99 times 10 to the power of negative 26 divided by M. So this is what we're going to find for 1U, mass for 1U. So cross multiply, so we get 1.99 times 10 to the power of negative 26 divided by 12. So mass in kilogram for 1U is equals to 1.66 times 10 to the power of negative 27 kilogram. So it is proven that 1U unit is equivalent to 1.66 times 10 to the power of negative 27 kilogram. Okay, from the equation, Einstein equation, E equals to mc squared. So C is the speed of light, and mass for 1U is equals to 1.66 times 10 to the power of negative 27 kilogram. So we substitute into here to get the energy equivalent to 1U. So we substitute this mass value times the speed of light. So we get the energy equivalent to 1U is 1.49 times 10 to the power of negative 10 joule. And to convert to mega electron volt, so we divide this value 1.49 times 10 to the power of negative 10. So divided by 1.60 times 10 to the power of negative 19, and then for mega we divided by 10 to the power of 6, so become 931 mega electron volt. So we can make a conclusion for these three value as 1 U equivalent to 1.66 times 10 to the power of negative 27 kilogram and 931 mega electron volt, and equivalent to 1.49 times 10 to the power of negative 10 joule. Okay, next, what is mass defect? So mass defect of a nucleus is the difference between the mass of a nucleus and the sum of the masses of the nucleons of which it is composed. So in the mathematical form, we write as total mass of constituent nucleons minus mass of nucleus. And what is binding energy? Binding energy of a nucleus is the energy required to completely separate its constituents nucleons. So binding energy of a nucleus is the energy equivalence of the mass defect given by E equals to mc squared. So three things need to be known in order to calculate the mass defect. First is the actual mass of the nucleus. Second is the composition of the nucleus, means that how many the number of protons and number of neutrons. And the third is the masses of a proton and of a neutron. So example for helium nucleus. So mass of the helium nucleus is 4.00260 U, okay, in terms of U. And then next, the composition of a nucleus, helium nucleus is 2 protons and 2 neutrons. Okay, separately 2 protons and 2 neutrons. So the masses of the proton and of a proton. Okay, so we add up these 2 protons plus 2 neutrons. So the masses of a proton is 1.008665 U, and mass of the proton is 1.0067825 U. So we add up the masses of each proton and of each neutrons that make up the nucleus. Okay, 2 protons plus 2 neutrons. So we get 4.03300 U. Okay, next, to get mass defect, so we compare these two. Okay, then we subtract the actual mass of the nucleus from the combined mass of the components to obtain the mass defect. So 4.03300 U minus 4.00260. So we get 0.03040 U. Okay, to convert this mass defect into energy, so we use Einstein equation, E equals to mc squared, and then don't forget to convert the mass into kilogram. So 1 U is equals to 1.66 times 10 to the power of negative 27 kilogram. So from the equation here, 0.03040 U convert to kilogram, multiplied by 1.66 times 10 to the power of negative 27. Then this is the speed of light, then squared. So we get 4.54 times 10 to the power of negative 12 joule. So this is the unit of energy equivalent for the mass defect, 0.03040 U. And in terms of mega electron volt, so we 4.54 times 10 to the power of negative 12 divided by 1.6 times 10 to the power of negative 19, and then divided by 10 to the power of 6 for mega. So we get 23.3 mega electron volt. Okay, another method, we can use this equivalent 1 U to 931 mega electron volt. Okay, so from this 0.03040 U times 931, we get from this one, so we get 28.3 mega electron volt, same answer as the previous method using E equals to mc squared. Okay, next we discuss example 2. Calculate the binding energy of an iron 56 nucleus given that mass of iron nucleus is 55.9349 U and mass of one neutron is 1.008665 U and mass of proton is 1.007825 U. So to calculate the binding energy, first we need to get the total mass of 26 protons and 30 neutrons. So iron consists of 26 protons and 30 neutrons. So using how to get 30 neutrons, so from the symbol here, 26 is the Z number and 56 is the A. So to get number of neutrons, so that's mean 56 minus 26. A is number of nucleons, so nucleons consist of proton and neutron, so 56 minus 26 we get 30 neutrons. So the total of mass will be 26 times 1.007825 plus 30 times 1.008665. So equals to 56.4634 U. Okay, next, given the mass of iron 56 is mass of the nucleus is 55.9349 U. Okay, from the question here given. Okay, next, mass defect will be compare these two values. So 56.4634 U minus 55.9349. So we get mass defect equals to 0.5285 U. So for binding energy, there are two methods to be used. First, we use the equivalent energy for 1 U is 931 mega electron volt. Okay, so we proved in the previous slide that energy for 1 U is 931 mega electron volt. So we use this straight away. 0.5285 times 931, so we get 492 mega electron volt. Or another method, we use Einstein equation, E equals to mc squared. So substitute m is 0.5285 times 10 times 1.66 times 10 to the power of negative 27. Okay, to convert the unit U to kilogram. Okay, then C is 3 times 10 to the power of 8, speed of light, then squared. To convert to mega electron volt, we divided this value divided by 1.6 times 10 to the power of negative 19, and using prefix mega, so divided by 10 to the power of 6, so we get 492 mega electron volt. So this is same as the previous answer. So there are two methods to calculate the binding energy. Okay, so that's all for the video. Thank you for watching, and don't forget to subscribe, like and comment.